Hello from California. It's great to have a great opportunity here to talk to all of you. And yes, as Chris mentioned, I'm here to talk about getting data into the InfluxDB. So let's start with the basic question, which is, why is data ingestion so important? Simple answer, database isn't terribly useful without data in it. So getting your data into the database is a necessary first step, so that then you can start deriving value. And that's really the key element here, which is, how do you derive value from your data? Having data in a database is one thing, but getting the value out of it is what's so important. So data in its raw form has limited value, but analyzing it turns that into knowledge. So for example, I may know that the temperature of some particular monitor is 90 degrees. Knowing that it's 90 degrees tells me one thing, but knowing that an acceptable range is 70 to 80 degrees and that 90 implies it is overheating is what gives it the value. And the less time a user spends getting their data in, the more time they can spend on deriving that knowledge from the data. We did a Cloud2 user survey and found that the Net Promoter Score doubled for users had completed the data ingestion step, because they were able to start deriving more value from their data, and as a result, they started deriving far more value from the service itself. So how do I get the data in? There are a number of different approaches to how you get data into Influx, and they really change based on your situation, your application, your data sources, your network configuration, your environment. I'm just going to go through the different choices that are available. So the first one is probably the most well-known one, is using an agent, in this case, Telegraph. So Telegraph is an agent-based solution that enables you to pull data from a whole variety of data sources and send them to a whole variety of data destinations. Telegraph isn't specific to InfluxDB, but in this example, I'm using it where it's sending the data to InfluxDB. So you configure your input plugin to pull data from whatever the data source happens to be, and then an output plugin to send it to wherever it needs to go, in this case, InfluxDB. The agent itself adds a level of resilience, taking care of things like retrying in the case of failure, batching up the data. So you get the added value of an agent managing how your data flows from whatever your data source happens to be to wherever your data destination. We've got over 200 Telegraph plugins today. They fall into four main categories. Input plugins, which are for pulling data from your data source into the Telegraph agent. Output plugins to send it on to whatever the destination is for that data. Processor plugins, which enable you to do some type of transformation of the data to make it more suitable to the ultimate target. And then aggregator plugins, which are very useful for the case where I don't want to send all the raw data. I may be accumulating a lot of raw data, and so I want to do some amount of aggregation at the edge so that I'm only sending onto the database the stuff that I will actually be using in my analysis. Telegraph is an open source project. It's a very mature open source project. It's been around for quite a while. And it releases on a regular cadence of quarterly releases with monthly bugs fix releases. So 1.15 is just lined up and ready to go. If the Telegraph plugins happen to suit your needs, it really is the easiest approach. You can just configure it to work with your environment, work with your needs. You don't have to write any code. And we've been fortunate to have an extremely large community of contributors to the Telegraph ecosystem, which is what has led to having over 200 plugins in place already. So Telegraph is just one approach where you effectively have a standalone agent running in its own environment, pulling the data in and sending it on. Another approach is to use the client API. So in the client API approach, you can embed the logic directly into the data source so that it takes care of sending data to the Influx database. This probably makes more sense for some custom applications where you have the flexibility to modify how the application works. And so it's all in one unit. And the client API will then take care of things like retrying, converting the data into the form that InfluxDB expects it to be in. So for client APIs, we have a large range, 9 different libraries today. We've got Python, C#, Java, and Go, JavaScript, Ruby, PHP, Scala, and Kotlin. And as I mentioned earlier, the client API does take care of batching, chunking, setting the headers appropriately, so it hides all the details of what it takes to get the data to the Influx database. The third approach is where you're pulling the data. So you're doing an agentless pull or scraper style approach. And so Flux supports this. Some of you, I'm sure, were at the Flux workshop last week. It is our new functional query language, and it enables you to write queries that also take care of pulling data from data sources as part of the query itself. So this gives a very seamless approach for pulling your data in and manipulating your data. I'll be going through this in a little more detail later on. So you can use, we have a Prometheus scraper, or there's a variety of .from methods in Flux today, and more of them will be coming in the future. And as I mentioned, this one doesn't require an agent. It runs directly within the InfluxDB environment, pulling the data in as needed. The last approach is native, where your data source takes care of generating the line protocol directly to send data into the InfluxDB. So line protocol, if you're not familiar with it, is a text-based format for writing data into the Influx database. And so there are a variety of products that just generate that directly itself. So for example, JMeter, FluentD, the Influx command line interface for CSV import is generating it. So this, if this is supported, this can be a pretty easy integration approach. So what I've outlined so far are the 4 general approaches for getting data into the InfluxDB ecosystem, so that you can then move on to the real job, which is how are you using that data to learn about your systems and take action based on what the data is telling you. I'm now going to go into a little more detail on Telegraph, because it is a really important part of the overall Influx ecosystem. So as I mentioned, Telegraph is an open source project. Over the years, it's been used for collecting metrics from a huge variety of different sources and writing to a huge variety of data syncs. I'm certainly not going to list all of the Telegraph plugins, but these are just a small subset of them. So for databases, for example, we've got plugins for the MongoDB, MySQL, Redis. For systems, you can pull metrics from cloud platforms, from containers, from orchestrators. In the IoT space, you can collect stateful data, pressure levels, temperature levels, etc., from various IoT sensors and devices. If you're interested in seeing the range of Telegraph plugins available, the source is available at github.com. So check it out. We've been seeing recently, we've been seeing some really interesting cases. We've got a customer, for example, who is tracking COVID-19 data in South America, and they're using the exec input plugin to pull data from public websites and then parsing the JSON to extract the relevant fields and make some really, really interesting graphs with the output. So sky's your limit in terms of what you use a Telegraph plugin for. As I mentioned, it is a a plugin-based architecture. So you can have any mix of input plugins, processor plugins, aggregator plugins, and output plugins. Whatever you need to cover your particular use cases. There are over 170 different input plugins available today, and there are over 30 different output plugins available today. So any mix of input, output for whatever your use cases will take. So you might say, well, that's great, but believe it or not, 170 different input plugins isn't enough. My particular use case is not covered by the Telegraph plugins in use today. So great. What do you do about that? You add your own Telegraph plugin. Telegraph is a Go executable, and so the plugins all need to be reviewed to make sure that they'll coexist well within the agent. They are all baked into the same Telegraph agent. And so as a result, there is a little bit of a process involved in adding a Telegraph plugin. So you've to sign the license agreement to agree that you're willing to have your software be distributed as part of an open source project. You then, I would encourage you, create an issue to describe your plugin. You'd be surprised. It could be that there are others working on a similar issue, or you might get a recommendation saying, hey, instead of starting from scratch for your particular plugin, all you have to do is extend on an existing one that may match your needs. Maybe you do need a completely brand new one, but we can provide feedback on that too. When you're ready to go, you submit a PR for your new plugin following the guidelines on what plugins need to do. We'll review it. You need to respond to that feedback, update your PR based on the feedback you get, and then ultimately the plugin will get added to a future Telegraph release once the review is complete. So this process is what we've been doing for many years. It works well, but it can take some time. There are plugins which have taken quite a while to get through the whole review cycle because for the more complex plugins, it can be a significant amount of work for us to ensure that those plugins are coexisting well within the Telegraph agent. So one of the things I'm excited to describe is a new approach we're introducing in Telegraph 1.15, which gives a new level of flexibility around the Telegraph development and release lifecycle. And so what we're doing is we're introducing a concept of an external plugin. So an external plugin basically runs in its own process. Instead of running inside the Telegraph process, it runs in its own process. And so because of that, there's degrees of flexibility that the internal plugins don't necessarily have. We don't need the same level of review and rigor by the Telegraph team. As the manager for the Telegraph team, I'm quite excited by this. The Telegraph team are kept very busy in the review process, and this is a way to give more flexibility to the community to enable more plugins to get out there without going through a fairly rigid review process by the Telegraph team. The API is designed so that the exact same API that works for an internal plugin can be used for an external plugin. So when you're developing the plugin, you don't have to even decide, do I want it as an internal or an external plugin? You develop it exactly the same way with exactly the same API, and then it's based on a configuration as to whether you decide to run it as an external plugin or not. The external plugin approach, where the plugins are running inside a separate process, also opens up some new use cases that can't be supported by internal plugins. For example, a non-Go plugin or a plugin that needs access to some library that isn't available in the Go ecosystem. You can also use this as an approach. We've seen some people who've had difficulty where their plugin has relied on some licensed software that isn't available in the open source community. And so this gives you a level of flexibility because the plugin is running in its own process. And you can use this for any type of plugin, whether it's the inputs, the outputs, the processor, or the aggregator style plugin. So I'm very excited, and I think this may become my most popular plugin at the end of all this, because it really opens up a level of flexibility around how plugins get configured. So let's look in a little more detail as to exactly how this external plugin architecture is designed. So from the Telegraph perspective, so I've got the Telegraph process there on the left. It's configured to have input plugins, processor, aggregator, and output plugins. And the execd is simply another input plugin. What's a little different about the execd input plugin is that it's reading standard out. So in this example, I have a separate process, my custom input, and in that separate process, I'm writing metrics in Influx line protocol, and I'm just writing them to standard out. So it's a long-running process, and it just writes to standard out, and the execd input plugin is configured to read from standard out. So to the rest of the Telegraph ecosystem, it looks exactly the same as if it's embedded, but your process has the flexibility of running as an independent process. So an custom input plugin just writes to standard out and gets picked up by the execd input plugin. A processor one reads from standard in, writes to standard out. So it reads metrics coming in Influx line protocol, writes them out in Influx line protocol format again. Same style for the aggregator one, reads from standard in, writes to standard out. And then the output one reads from standard in, and then outputs the data to wherever it needs to be. Now, you certainly don't need all four external plugins. This is just showing the complete example. You can write an external plugin for whatever your use case could be. We've already seen a Twitter external plugin, input plugin for reading from Twitter. So here's an example of what the configuration looks like. It's pretty simple. This is an input plugin. The input's execd. You just give the command that you want to be invoked. We start the process, and then it's a long-running process. In this case, Telegraph Smart Control is running. You can pass command line arguments to it, in this case -d, dev SDA. You can have an option for whether the process needs to get nudged via some signal to produce input, or whether it just generates inputs directly itself and just writes to standard out. And you specify the format that we should expect. In this particular example, we're expecting the format to be in line protocol. So this approach doesn't replace the approach we have today with internal plugins, but it gives you a lot of flexibility. You can start by developing your plugin as an external plugin, and then over time, maybe we see enough popularity for it, we see a lot of interest, so we bring it into an internal plugin. We're also considering taking some of our older plugins that maybe aren't getting broadly used and moving them to being external plugins. So we have a lot of flexibility. This is just the early days, and I'd love your thoughts and your input on what you think the best approach should be. But I encourage you to check this out in 1.15 and play around with it yourself for your own external plugins. Another area in 1.15 that we've found a way to lighten the burden for some common use cases is in the area of processor plugins. One of the things we had noticed was there are often processor plugins that are really just doing some fairly basic data transformation, whether it's some easy math or some string expressions. There isn't a huge amount going on in a lot of these processor plugins. So instead of having to have your own special plugin, we've introduced Starlark as a processor plugin approach. So Starlark, used to be known as Skylark, is a dialect of Python. And don't get too excited, you're not getting the full power of Python inside the plugin. It really does provide a sandboxed environment for running a fairly lightweight script, which will enable you to do some basic manipulation of the data. So in that sandboxed environment, you don't get to access the file system, the network, the system resources, but we found a lot of the processor use cases can be supported with a very simple scripting language such as Starlark. So let me give you an example of what that looks like. You invoke the Starlark processor plugin. You pass in the source. You can either pass it directly in the config file, or you can reference another file that contains the source. And inside that script, you need a function called apply. It's going to take the metric as its single argument, and then it returns either none if it is going to suppress that metric, for example. It can return the same or a different single metric, or a list of metrics. So in this example, slightly contrived example, I pass in a metric, and it's going to multiply the value times 10 if the type of that metric is a float. So for simple manipulations, whether it's string manipulations, mathematical calculations, sometimes we see that there may be some minor change in format needed between the format the metric comes in natively and the format that InfluxDB expects. And so you can use the Starlark plugin as a way of doing that fairly lightweight transformation. So these are two new features coming in 1.15, and I really hope to see them add to the flexibility in how you're able to expand on the Telegraph ecosystem to support your particular use cases, whatever they may happen to be. So earlier on, I'd mentioned a little bit about Flux, our data scripting and query language. And the ability to integrate with other systems is a core design feature of Flux. Going right back to where I started, data turns into knowledge with added value from additional data sometimes. And so trying to pull in those additional data sources to be able to derive the most value from your time series data is a really important part of what Flux can support. So here are some examples of from methods that are currently supported. So influxdb.from to pull in from a InfluxDB database, CSV, SQL, sockets, Prometheus, HTTP to pull from a website, and we have an experimental one to pull from Google Bigtable. So this is just the start. Flux hasn't been around as long as Telegraph. I don't know if we're going to get to 170 Flux from methods, but who knows? So we will be adding more Flux methods in the future, but you certainly should feel motivated to add your own, contribute to the Flux project for whatever data sources might make sense. So this is really suitable for things like cloud-based data sources, where you don't need or run an agent to gather the data for you, and you can do it directly from within the query itself. So this is another approach to pulling data into the Flux ecosystem, and then from there be able to transform it into however you need it for your querying capabilities. So now you might ask, well, should I be using Flux or should I be using Telegraph? Well, it really depends. Telegraph is really suited for running near the edge or at the edge to collect data at the edge, transform it, process it, and make it ready to send to the InfluxDB. It provides a layer of resilience within the agent itself in the case of network issues between the edge and where your databases are. And so Telegraph gives you a tremendous amount of power around how you accumulate that data to ensure that it all makes it into your time series database. Between the processor and aggregator plugins, you can also do some amount of data manipulation at the edge so that what you're sending is in a very consistent format so that the metrics you're gathering can be used in a very consistent way. Flux, on the other hand, runs natively within InfluxDB, and it can pull from data sources on an as-needed basis within your queries, probably a little more oriented around cloud-based data sources, but no particular reason. It can pull from anywhere that's reachable. So assuming you can get to it from where Flux is running, you can pull it in there too. So there's no perfect configuration. I suspect in many situations, people will see needs for both. They may use combinations of Telegraph and Flux. The important thing is that you have an easy approach to be able to get your data into the InfluxDB so that you can then choose to start manipulating the data in whatever way makes most sense for you. So in summary, I hope I've given you a good understanding of the choices that you have to pull your data in so that you can start deriving the most value from that data. So whether you have Telegraph plugins that you're using, whether you're using the client APIs, whether you just natively generate line protocol directly from within your application, or whether you use the Flux from methods, I hope you find it very straightforward to get your data into the InfluxDB environment so that you can then start using it to really drive business value from that data, whether it's to understand what's going on in your world, whether it's to drive actions, alerts based on that data. It should be a very powerful part of your overall ecosystem. And so with that, I thank you, and I'll switch back to Chris.
Oh, you're not done yet, Barbara. There's plenty of questions. So I think before we get moving towards the questions, let's grab Barbara's questions. I think they're a bit unfair, but we'll ask them anyways, and Jesse will throw them into the Slack channel. So question number 1, where did Barbara go up? Question number 2, what is Barbara's favorite Telegraph plugin? I think she mentioned this a number of times. So that was a bit of a freebie. And question number 3, in her free time, what charity is Barbara most likely to volunteer with? That one is really tough, Barbara.
No. There's a clue. There's a clue.
Awesome. Okay, so if you can, if you want to answer those questions for the t-shirt giveaway, go ahead and throw your answers into the Slack channel. And all right, where do we start? So there's been a couple of questions that were also answered in the Slack channel. So, you know, previously you could always just fork the code and just write whatever plugin and not have to put in a PR. So how is that different to this new process that you outlined?
Sure, that's a great question. So yes, you absolutely can fork the code and just keep it yourself. The challenge with that is then to keep up. Every time we release a new Telegraph version, there may be other benefits in the new version of Telegraph that you want access to. So you've got a kind of an ongoing maintenance for your forked version, in that you have to keep effectively merging back in the latest Telegraph stuff. So in this way, you get a level of isolation for your code that you can basically keep it independently of the Telegraph process itself. And there's also a size consideration. We've seen some pretty substantial plugins, and so you might decide that you don't actually want them all incorporated. But yeah, there's certainly not a, it isn't a one or the other. It isn't a one size fits all. And for your use case, you may find forking the code is a perfectly acceptable thing to do.
Cool. So can you share with everybody the expected release date for 1.15?
I believe we're leaving a release candidate is coming out next week, I think. So early July.
Imminent.
Yeah.
Just around the corner.
Yeah.
All right. So MSR asks, what would you use to enrich raw data based in some data catalog? Let's say, for instance, enrich some IP address with FQDN based in some text file catalog. Would it be in some custom Telegraph plugin? And I actually think, we have a friend at Verizon that's actually doing this with a processor plugin. But go ahead. I'll let you answer.
Actually, yes, we are. We have a reverse DNS plugin that's coming out that is going to do exactly this. So you take the IP address, and then it will do reverse DNS and turn it into the fully qualified domain name. But yes, that's a great example, kind of conceptually, of a processor plugin. So it's taking raw data, adding some level of value to that data at the edge, so that when it comes up to the cloud, you've got the fully qualified domain name rather than just an IP address.
Or you can just memorize all those domain names with those IP addresses. Up to you what you want to do, right?
You go for it, Chris. I'm not saying anything about your.
All right, Nikki asks, Go apps have the tendency for notoriously large binaries. Are external plugins a way to help combat bloat?
Absolutely. So yes, that is actually one of the factors that went into beginning to promote this as an approach, because we are seeing that the Telegraph plugin is the Telegraph agent is getting bigger with every new release. As we add more plugins, it's getting bigger, and so this is a way of combating that.
Cool. So Peter asks, how can you integrate Oracle WebLogic with InfluxDB? Or is it directly Oracle DB with InfluxDB?
I may phone a friend on this one. So, Paul, you want to chime in? I see you sitting there.
Sorry, can you repeat the question?
So integration with Oracle WebLogic or Oracle DBs in general. And also he has a follow-up question, integration with Oracle Enterprise Manager, which is basically their monitoring tool. I think, Peter, if we don't have an answer, we'll get back to you in the Slack channel.
Yeah, in terms of what we have slated on our roadmap for us to produce, those aren't really necessarily on the roadmap, but the truth is we want to integrate with as much as possible. So we're happy to take community contribution, or on the other side of it, if there's enough interest from the community or we have enough customers asking us for it, that's certainly something we can get in.
Okay. And you know what, Peter, there's a lot of people in, today's sessions. Who knows, just maybe we can have a little chat in the Slack channel. Maybe somebody has some other ideas for this one. Let's see, another question. Are there any limits for the Flux from methods, especially the HTTP one?
There are performance considerations. In terms of the sheer volume of data that you bring in one call, but not specifically offhand, unless Paul is our resident expert on Flux. Do you want to bring in, you have any stronger considerations?
We do have some stuff on the roadmap for more bulk data transport that will involve different, basically bulk formats that would basically sit outside of the Flux processing pipeline, because Flux is more designed for, at least for tasks and stuff like that, for smaller bits of data that you might pull in, not like necessarily creating some sort of like replication pipeline, for example.
Awesome. Let's see, this one should be easy. Is the OPC UA plugin included in 115?
I believe it is. I need to absolutely confirm that, but I'm pretty sure that one is, yeah.
Okay, and then we have a couple questions that are a little bit more generic, so it's not just pertaining to Telegraph. So could you confirm the best practice for the data structure, the amount of fields versus the amount of tags? For example, short-term data, is it better to keep more tags over fields versus long-term, better to keep more fields and tags? What are your thoughts?
It really depends on your use case. I don't know that there's a one size fits all. I think you need to watch for cardinality. That's probably the main factor to take into account. And it's really a question of how, what's the best model for your approach. It's certainly something we can go through on a case-by-case basis, but I don't think there's a simple, you should prefer tags or you should prefer fields. It's really a matter of what makes most sense for your particular use case and the kind of queries you're trying to do and how you're trying to act on the data.
Claudio asks, are there any plans for supporting ingestion via binary protocols, like a protocol buffer?
Protobuf? Yes. So we can support any format that we need to pull things in. Ultimately, it needs to be data that can get represented inside the database. But certainly, there's nothing that says it has to be a text format coming in. So that's one of the benefits of Telegraph, is you can pull it in, and for example, in protobuf, parse the protobuf, pull out the values that you need, and then send them on the align protocol to InfluxDB.
Awesome. So Yash Singh has a question about Flux. And Yash, I'm going to ask you to put that in the Flux channel. Basically wants to know how to be able to do queries across measurements. And there's a pretty detailed question here, but why don't you post that into the Flux channel? There are plenty of people that would be happy to answer that, including some of the people that went to the training 2 weeks ago. All right, so I was completely wrong, Barbara. People do know more about you than I realized. So
see,
let's go through the questions. All right, where did Barbara grow up? And it's Dublin, Ireland, if you can't tell from the accent. And what is Barbara's favorite Telegraph plugin? It's the execd plugin.
See, they were listening. They were listening.
They were listening. And then in your free time, Barbara, what charity do you like to support the most?
Am I supposed to answer that?
I'm just, yeah, why don't you answer that?
CASA. I'm a court
There you
appointed
go.
special advocate. See, you just have to look at my LinkedIn profile. I told you, it's out there.
Yep, you're right. And so with that, looks like Alistair Thin and Jay Clifford and Tom Carmichael. You guys are all the winners. You got all those answers correct. So congratulations to that. Let's see, let me just do one more check to see, are there any other questions for Barbara? I think we're good. Emily, can you confirm for me? I think we're okay. All right, cool. Well, thank you so much, Barbara. And hopefully we'll see a lot more contributions and a lot more cool things happening with Telegraph.
Absolutely.